Hey guys, coming at you with another incredible video about math. This time, we're talking about dilations outside the origin. So, let's take a look at what a dilation is. Then we're going to go over 3 examples. That's 3, not 4, 3. Pinky was trying to get some attention. 3 examples of dilations and the types of questions we could ask. Alright, let's get started. So, what is dilation? Dilation is a transformation that produces an image of the same shape but stretches or shrinks. Now, a couple of things I want to point out about that. First off, it's not mentioned in this definition, which I looked up, that the stretch or shrink is occurring usually by a scale factor, which is a form of multiplication. So we're doubling or tripling in size, or halving the size or quartering the size, something like that. But it's multiplication that's occurring. Then, and this is an important definition for other parts of geometry, the sides get longer, but the angles stay the same. Okay, there's a whole nother concept of similarity that comes from dilations. So, let's take a look at what we got. So here's the first example. We're going to dilate by a factor of 2 with the center at -5, 4. So let's talk about what's going to happen here before I start this problem. So for starters, it's going to double in size. It's going to get larger, right? Then there's a second concept here. Besides it getting larger, this is the center dilation. So as we get larger, or as we apply the scale factor, it's actually going to move away. So it's going to move away from that. So let's take a look at how we can do this. I'm going to draw out some lines here. And I'm going to use blue. So I'm going to draw out these lines out here. There's that one. There is that one. And here's this one. What I did is I drew lines from the center of dilation, right? This is the center of dilation. And to the points on the triangle and drew them out. Now, what I'm going to do is I'm going to dilate this thing. I could use a ruler and double the distance. So, like, this guy is going to end up out here, that's going to end up out there, and this one's going to end up out there. But you don't always have a ruler handy. So what I'm going to do is I'm going to count by using the rise over run kind of method, the slope. So for this guy, I'm going to rise up 2 and run 2. So rise up 2 and run 2. So when I double that, rise up 2 and run 2, it becomes rise up 4 and run 4. And I end up over here. I'm going to do that here. So I'm going to, let me do this one next. I'm going to rise 3, 1, 2, 3, then run 1, 2, 3, 4, 5, 6. So rise 3, run 1, 2, 3, 4, 5, 6. Okay, it does require careful counting. So one more time, running 3, rising 3, running 1, 2, 3, 4, 5, 6. Okay, so I'm going to double that. So I'm going to rise 6, 1, 2, 3, 4, 5, 6. Then I'm going to run 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, there's that point. Now I'm going to do my last one. This one goes up 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. And over 3. So now I have to take that 7, 3, and double it, so it's going to become 14, 6. Again, careful counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then 1, 2, 3, 4, 5, and 6. Notice how my lines here kind of provide me as a guide. I would know if I messed this up if my point was, let's say, out here or over here, okay, or my points were not landing on my guiding lines. They are very, very helpful. So from there, I can draw my new triangle, okay, and I'm just connecting the dots at this point. And there we go. So this here, I'm going to try to color it in a little bit, is my triangle that is dilated. Okay, it is double the size of this one, and it still lines up with the center dilation. All right, so there is that one. Next, so this one here says dilate by a factor of 1/2 with the center of dilation at 5, 4. Okay, so let's talk about what's going on here. I moved the center of dilation up a little bit, and now we're changing the scale factor to 1/2. So instead of it getting larger, like before, it doubled in size, this time it's going to shrink. It's going to be half the size. Okay, that's the first observation. Second, before, when we doubled in size, okay, we moved away from the center of dilation. This time, because we're halving the size, we're moving towards the center of dilation. The center of dilation, again, being right here. So I just want to label that center of dilation. Okay, now, from there, I'm going to draw my lines again. I find these lines to be so helpful. So I'm going to do that. Here's this one. Here is this one. And here is this one. Okay. Let's take a look now. So there's some counting I got to do here. This guy is 1, 2, 3, 4, 5, 6, 7, 8, 9 away, then 2 down. So 1, 2, 3, 4, 5, 6, 7, 8, 9 away, and 2 down. Okay, well, what's half of 9? 9 over 2, of course, or 4.5. And in this case, as much as I don't like fractions, decimals, we're going to have to stick with the decimal. So it's about 4.5. And here's where that guiding line comes in handy. 1, 2, 3, 4. 4.5 is about right here. Then I have to move down 2 to get to this point, so I only move down 1. So it's about there. Okay, this one I'm going to go, let's see, how am I going to do this? I will go down 1, 2, 3, 4, and then move over 1, 2, 3, 4. So this point that I have here is going to be roughly 2 down, 2 over, and it's about there. Now for the last one. And notice how these lines kind of are overlapping. I know my point's there. I purposely separated the lines a little bit so it was easier for me to see it. Now, from there, I have this guy to get to. So 1, 2, 3, 4, 5, 6, 7, 8, 9 again. Then 1, 2, 3, 4, 5, 6, 7, 8. All right, let me make sure I'm counting correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8. So down 9 over 8. 9 over 8, I divide that by 2, okay, 9, 8. So I'm going to have 4.5 by 4. So 1, 2, 3, 4, 4.5. Here we go again. This is a lot of guesstimating going on here. But these bars, or these lines that I drew, are going to make things a little bit easier. 1, 2, 3, 4. See how I landed on that? Okay, so here's my dilated image. Okay, half the size, and a little and closer to the center dilation, a little bit closer to the center dilation. Where the other one was double the size, I'm going to pull that one back out. This one was double the size and moved away. Half the size, closer. Double the size, farthing away. So there's a pattern here. For when it's larger than 1, we're going to get larger, and we're going to move away from the center of dilation. When the scale factor is less than 1, then it's going to get smaller, and we're going to move closer to the center of dilation. All right, last question here. So this question is asking, how do I find the center of dilation? Well, remember those fancy lines I drew? They apply to this too. I could use the same exact method, and that's what I'm going to do. I'm going to get my trusty ruler. Now, keep in mind, you don't always have your ruler, but you have a calculator, you have a pencil, you have a folded piece of paper maybe, any kind of tool you could use. And I am drawing my lines, okay? Sometimes what I will do, I will associate my points with each other, but I messed up that line there. All I'm doing is applying my ruler to the lines that correspond, to the angles that correspond with each other. So this angle and this angle correspond. They line up. This angle and that angle correspond. And that angle correspond. So I drew those lines, and you see where they're converging? Well, this is my center of dilation, right there. Center O dilation. Okay? There it is. And that's it. Sometimes you'll be asked to label it. So let's see if that's negative 10, 11, 12, 13, negative 13, negative 1. Something like that. Okay? And that's it, folks. So I hope you found this video helpful on dilations outside of the origin.